Let us try to see the property theorem. What is that? 30, 60, 90 triangle. First, let the triangle ABC. In that triangle, AB is equal to BC is equal to AC. Let the value of each side is 2x. So, suppose this is 2x, this is 2x. And all sides are equal, so it must be equilateral triangle. So what is the value of each angle? It must be 60. You know this property of equilateral triangle. So what is the measure of each angle there? 60, 60, remaining also 60. Now let us draw that AD perpendicular to the side BC. When we draw perpendicular, you know that it is 90. What is the measure of angle D? It is 90. And angle C is 60. And you know that sum of all angles in any triangle is 180. So remaining angle you can calculate very easily. And your answer is 30. So in triangle ADC it is 30, 60, 90. So let us find out properties of triangle ADC. Of course, it is right angle triangle and remaining angles are 30, 60, 30, 60. They are complementary. You know that in this triangle ADC and second triangle ADB, we can observe AB side and AC side, AB and AC. There. What is that? This is hypotenuse and this is hypotenuse. In this right angle triangle and in the second triangle, AD is common side. So if you ask question to both triangles, what is that you are finding? Hypotenuse congruent, hypotenuse congruent and side congruent. So by hypotenuse side theorem, definitely two triangles are congruent. And when the two triangles are congruent, corresponding sides are congruent. What is that? BD and CD are congruent. So what is proved now? When we draw perpendicular there, we can prove that BD and DC equal. But we have taken that BC is equal to 2x. So what is this length DC? It must be equal to x. And what is this? This must be equal to x. Now very easily you can ask question side opposite to 30. Side opposite to 30, how much? X. And in that right angle triangle, what is the length of hypotenuse? 2x. So you can compare that. What is that value x? What is the relation of x with 2x? You can say easily it is half of hypotenuse. So this is one of the very important property. What is that? Side opposite to 30 is half into HYP. This is known as 30, 60, 90 theorem. What is that property? In any 30, 60, 90 triangle, side opposite to 30. Side opposite to 30 is always half of hypotenuse. It is always half of hypotenuse. So if this is 20, what is the half? 10. If it is 4, what is the half? 2. If it is 200, what is the half? 100. Like that. In any right angle triangle, that is wrong. In right angle triangle, if the values are 30, 60, 90, then definitely we can use this property. It is the side opposite to 30 is always half of hypotenuse. So if you know that this is relation and if you take that side opposite to 30 divided by hypotenuse, it will be 1 upon 2. If you go further like that and if you use the rules of equation, side opposite to 30 divided by hypotenuse, you are getting a ratio there. And this ratio Trigonometry, you know that opposite upon hypotenuse, that is nothing but sine, and it is the sine of 30 is equal to 1 upon 2. So this is the relation there. Sine 30 is 1 upon 2, we know that, and in this theorem only you can use that side opposite to 30 is half of hypotenuse. Now next thing, let us try to find out what is the value of side opposite to 60 in this triangle ADC. Now we know that DC is x, it is opposite to 30. AC we have taken 2x with hypotenuse. Now we can use Pythagoras to calculate AD. So what is that Pythagoras? That is your next step in triangle ADC. Use Pythagoras. AD square plus DC square is equal to AC square. Substitute proper values. This is Pythagoras. What is that? AD square plus DC square. It is x square, and AC is 2x. So you know that what is the ultimate result there? AD square is equal to 4x square minus x square, and it is 3x square, and it is the value of AD square. AD square. AD square is equal to 3x square. So definitely you can calculate AD is equal to under root 3x, and this is nothing but it is the side opposite to 60. Side opposite to 60. So what is the next result we are getting there? Side opposite to 60. Side opposite to 60 is equal to root 3 into x. Root 3 into x. But it is root 3 upon 2 into 2x. Very interesting. Root 3 upon 2 divided by 2 into 2. 2 divided by 2, value is 1. So what is that? Root 3 upon 2 into 2x, and 2x you can see that it is nothing but hypotenuse. So what is the important property we are getting here? What is that important property? It is like this. It is, you can read, side opposite to 60 is root 3 upon 2 into HYP. So again you can try to find the ratio. Side opposite to 60 divided by hypotenuse is equal to root 3 upon 2. And you know that opposite upon hypotenuse, it is again sine ratio. So sine of 60 is equal to root 3 by 2. So very interesting relation. Sine 60 is equal to root 3 upon 2. Sine 30 is equal to 1 upon 2. So there is relation. Try to understand this relation. By using Pythagoras, we can find out side opposite to 60 is root 3 upon 2 into hypotenuse. And by using the property of equilateral triangle, we can find out side opposite to 30 is 1 upon 2 into hypotenuse. So this is very important theorem. Try to study this theorem. Okay.